Good morning, children. I am Mrs. Senir Karasi. Today we are going to discuss chapter 4, atomic structure. So in this chapter we are going to discuss general representation of an atom, electronic configuration, valency and chemical bond. General representation of an atom. So how we will represent an atom? Look at the picture. X, Z, A. So X indicates the symbol of the element and Z is its atomic number. A is its mass number. So what is atomic number and what is mass number? Atomic number. The number of protons in one atom of an element is known as atomic number of that element. So what is atomic number? The number of protons present in an atom is known as atomic number. And we all know that number of proton is always equal to number of electrons in an atom. So therefore atomic number is also called as number of electrons, number of protons or number of electrons. It is denoted by the letter capital Z. So what is atomic number? Nothing but number of protons or number of electrons. Now let us look at mass number. What is mass number? The total number of protons and neutrons present in one atom of an element is known as its mass number. It is denoted by the letter capital A. So mass number is equal to total number of proton plus neutron. So capital A, that is equal to P plus N. And we know that number of proton is equal to atomic number. Atomic number is equal to number of proton. So therefore we can rewrite the above relation, that is A is equal to, instead of proton we can use atomic number Z. Therefore A is equal to Z plus N. Okay. So what is mass number? Total number of protons and neutrons. P plus N is the mass number. It is denoted by the letter capital A. Okay. So we already studied that electrons are revolving around the nucleus, and we also know that the maximum capacity of each shell can be calculated with the help of the formula 2n square. Yes. So what is the maximum accommodation of K shell? 2. L shell can hold 8 electrons, M can hold 18 electrons and N can hold 32 electrons and so on. Okay, so now we will see how to arrange the electrons in a shell. So that is called electronic configuration. Electronic configuration means the arrangement of electrons in the various shells of an atom of the element. So that is known as electronic configuration. Let us take an example, oxygen. O816, oxygen 816. So what is number 8? 8 is nothing but the atomic number and 16 mass number. So you know that atomic number should be written as a subscript on the left hand side of the symbol and mass number should be written as a superscript on the right hand or left hand we can write. So atomic number as a subscript, mass number should be written as a superscript. Okay. So oxygen 816. Atomic number is equal to proton and electron. Therefore, oxygen has 8 proton and 8 electrons. To find out the number of neutrons, what we want to do? We want to subtract both the atomic number and mass number. So mass number 16 minus atomic number 8, that is equal to 8. So therefore, oxygen has 8 proton, 8 electron and 8 neutrons. So now we want to arrange the electrons. We want to arrange the 8 electrons in the shells of oxygen. So first shell is a K shell. So we want to keep 2 electrons in the K shell because the capability of K shell is 2. It can hold only 2 electrons. So 8 minus 2. So we kept 2 electrons in the K shell. Remaining 6 electrons will be placed in L shell because L shell can hold 8 electrons. So the electronic configuration of oxygen is 2, 6. K shell 2 electrons, L shell 6 electrons. Let me see some more examples. Nitrogen 7, 14. So 7 protons, 7 electrons. We want to subtract mass number and atomic number to find out the number of neutron. 14 minus 7, 7 neutron. Okay, so now we will arrange the 7 electrons in the shells. So K shell, 2 electrons will be placed in K shell, 7 minus 2, remaining 5 electrons will be placed in L shell. So therefore, electronic configuration of nitrogen is 2, 5. And sodium, 11, 23. So 11 proton, 11 electron, 23 minus 11, 12 neutron. So now we will arrange the 11 electrons in its shell. So K shell, 2 electrons, so 11, 2 electrons, remaining 9. 11 minus 2, remaining 9 electrons. And L shell can have only 8 electrons. So we will place the 8 electrons in the L shell. So 9 minus 8, remaining 1 electron, that will be placed in M shell. So therefore, the electronic configuration of sodium is 2, 8, 1. The next example is chlorine. 17, 35. So it has 17 proton, 17 electron. 35 minus 17, 18 neutron. So now we want to arrange the 17 electrons in its shell. So you know that K shell can have 2 electrons. Therefore 17 minus 2, remaining 15 electrons. L shell can have only 8 electrons. So we will keep the 8 electrons in its L shell. So 15 minus 8, remaining 7 electrons will be placed in M shell. So therefore, the electronic configuration of chlorine is 2, 8, 7. I hope you understood how to arrange the electrons in its shell. Okay, so how to draw the electronic configuration? So you want to draw the electronic configuration. So for nitrogen, you know that it has 7 proton and 7 neutron will be placed in the nucleus because nucleus contains proton and neutron. And electrons are revolving around the nucleus. K shell, 2 electrons we want to keep in K shell, and L shell we want to keep 5 electrons in L shell. So this is how we need to draw a electronic configuration. So likewise for sodium, here I have given. So 11 proton, 12 neutron will be placed in its nucleus, and first shell 2 electrons, second shell 8 electrons, and third shell M shell 1 electron we want to place. Okay. So you want to draw the electronic configuration as well as you want to write the electronic configuration. Okay children. Okay, so next we want to discuss what is an valence shell and valence electrons. So what is a valence shell? The outermost shell of an atom is known as valence shell. The outermost electron shell of an atom is known as valence shell. And the electrons present in the outermost shell of an atom is known as valence electrons. So the number of electrons present in the outermost shell of an atom is known as valence electrons. So let us look at the example. Lithium. So lithium has 4 neutron and 3 proton that will be placed in the nucleus, and it has 3 electrons. K shell can have 2, so 2 electrons will be placed in K shell, and 1 electron, remaining 1 electron will be placed in L shell. So now what is the outermost shell of lithium? L shell is the outermost shell of lithium. Therefore L shell is the valence shell of lithium. And how many electrons are there in L shell? 1 electron. Therefore valence electron is 1. So lithium valence shell is L shell, valence electron 1. Okay. Let me look at some more example. Carbon. So electronic configuration 2, 4. So what is the valence shell? What is the outermost shell? L shell. So valence shell is L. And how many electrons are there in the valence shell? 4 electrons. Therefore valence electron 4. Magnesium electronic configuration 2, 8, 2. So the outermost shell is M shell and it has 2 electrons. So valence shell M shell, valence electrons 2. And helium 2 electrons, K shell, 2 electrons will be kept in K shell. So it is the outermost shell. So valence shell is K and valence electron is 2. And fluorine 2, 7. So the outermost shell is L shell. Therefore valence shell is L. And it has 7 electrons in its outermost shell. Therefore valence electron is 7. Okay. I hope you can able to find out the valence shell and valence electrons. Okay. So now we want to know what is valency. Valency is nothing but the combining capacity of an atom of an element. So that is its valency. For example, water. Here oxygen combines with 2 atoms of hydrogen. So oxygen can able to have 2 hydrogen atoms, So therefore, the combining capacity of oxygen is 2. Oxygen holds 2 hydrogen atoms. Therefore, combining capacity of oxygen is 2. That means valency of oxygen is 2. And magnesium chloride. Magnesium holds 2 chlorine atoms. Magnesium holds 2 Cl atoms. Therefore, the combining capacity of magnesium is 2. That means its valency is 2. So, what is valency? The combining capacity of an atom is known as its valency. And valency of noble gases is 0. So, look at the periodic table. 118 elements were arranged in this table. So, the last one. So, this is called noble gases. So, the last group is called the noble gases: helium, neon, argon, krypton, xenon, radon. So, these are the 6 noble gases. So, the valency of noble gases is 0. What is meant by 0? 0 means, that means they don't have any combining capacity. They won't combine with any other elements. So that's why it has valency 0. Why they won't combine with other elements? Because they have a completely filled outermost shell. So that's why they won't combine with any other elements. They are chemically unreactive. So noble gases are very stable and considered to have a most stable arrangement of electrons. They have 8 electrons in its outermost shell. Neon 2,8, argon 2,8,8. So they have a completely filled orbitals. They have 8 electrons in its outermost shell. So that's why noble gases are the most stable electronic configuration. Okay. So how can we calculate the valency of metals and non-metals? So you know that 118 elements were broadly classified into metals and non-metals. So look at the periodic table. So there is a zigzag line here. So in this side we say these elements are metals and these elements are non-metals. So here these are all metals and these are all non-metals. 118 elements were broadly classified into metals and non-metals. And this pink color, these are metalloids. We say these are all metalloids. They show the properties of metals as well as non-metals. These are all called as metalloids. These elements are metalloids. These elements are metals and here non-metals. So how to find the valency of metals and non-metals? So it is very simple. So valency of metal is equal to number of valence electrons in its atom. So it is easy for us to find out the number of valence electrons. So number of valence electron equal to valency of metals. Valency of non-metals, what we want to do is, we want to subtract the valence electrons from 8. 8 minus number of valence electrons. So it is easy to calculate the valency of metals and non-metals. Let us look at the example. Sodium 1123. Electronic configuration is 2,8,1. So outermost shell, valence shell, and the electron which is present in the valence shell is known as valence electron. Therefore, valence electron is 1. Valence electron is 1. Therefore, valency is also 1. And magnesium 2,8,2. Valence electron 2. Therefore, valency also 2. And oxygen 2,6. So valence electron 6, we want to subtract from 8. 8 minus 6 equal to 2. Valency of oxygen is 2. Fluorine 2,7. So valence electron 7, we want to subtract it from 8. 8 minus 7 is equal to 1. Okay, so how to know that which are all the elements or metals and which are all non-metals? So generally, valence electron 1, 2, 3 belongs to metals. Valence electron 1, 2, 3 belongs to metals. 5, 6, 7 belongs to non-metals. So 1, 2, 3 means the valency is same. Valence electron 1, 2, 3 means valency also 1, 2, 3. Valence electron 5, 6, 7 means we want to subtract it from 8. 8 minus 5, 3. 8 minus 6, 2. 8 minus 7, 1. Okay. So it is easy for us to calculate the valency of metals and non-metals. Okay, so now let us discuss about chemical bond. What is a chemical bond? So chemical bond is nothing but the attractive force. It is an attractive force which holds the atoms, ions or molecules together in a chemical compound. So two or more elements combine to form a compound, and there is an attractive force between the atoms. So that attractive force is called as chemical bond. Here you can see this example. Two hydrogen atoms combine to produce a hydrogen molecule. So there is an attractive force between these two hydrogen atoms. So that attractive force is called as chemical bond. Okay, what are the types of chemical bond and why a chemical bond is formed? What is the reason for the formation of a chemical bond? There are two main reasons. Number one, to acquire a stable electronic configuration. So that is the main reason. So we know that the noble gases have the most stable electronic configurations. Therefore, every atom out of 118 elements, 6 only noble gases, those have stable electronic configuration. So remaining elements, so all the atoms want to have 8 electrons in its outermost shell in order to acquire the stable noble gas configuration. So that's why they form chemical bond. And in order to acquire minimum energy, so if they have a stable noble gas configuration, then they acquire a minimum energy. After that, it attains maximum stability. So the compound becomes more stable. So that's why a chemical bond is formed. Now let us look at the types of chemical bonds. First one, ionic bond. Here electrons are transferred. So look at the picture. The electrons are transferred from one atom to another atom. So here, and it was formed between metals and non-metal atoms. So metal always gives an electron, donates an electron, and non-metal accept that electrons. So electrons are transferred in ionic bond. And the next one is covalent bond. Covalent bond means here electrons are shared. Sharing of electrons will take place in covalent bond. So covalent bonds are formed between non-metal atoms. Okay, so let us look at the example. How an ionic bond is formed. We know that what is an ionic bond. Ionic bond is a chemical bond formed by the transfer of electrons from one atom to another. Ionic bond is also called as electrovalent bond. So how an ionic bond is formed? By the transfer of electron from one atom to another. Okay, so let us take the example potassium chloride. How potassium chloride compound were formed. Let us take potassium. The electronic configuration of potassium is 2, 8, 8, 1. So according to octet rule, it should have 8 electrons in its outermost shell in order to achieve the stable noble gas configuration. So now potassium want to lose one electron in order to have 8 electrons in its outermost shell. So potassium loses one electron. Okay. So potassium atom has 19 proton and 19 electron. Proton is positively charged and electron is negatively charged. Therefore, plus 19 minus 19 is equal to 0. So, potassium atom is electrically neutral. Potassium atom is electrically neutral. And it loses one electron. So, after that, what happens? 19 electrons becomes 18 because it loses one electron. There is no change in proton. So plus 19 minus 18, that is equal to plus 1. So potassium acquires a positive charge. It acquires a positive charge. So potassium atom changes it to potassium ion. So the ion which have positive charge is called as cation. So cation. So this is how cation is formed. Potassium atom is converted into potassium ion by losing an electron. Okay. So chloride ion. How chloride ion is formed? The ion with a negative charge is called as an anion. So chlorine. The electronic configuration of chlorine is 2, 8, 7. So in order to have 8 electrons in its outermost shell, chlorine needs one electron. So it wants to gain one electron. So what chlorine is doing? It gains one electron. So the chlorine atom has 17 proton, 17 electron, plus 17 minus 17 is equal to 0. So chlorine atom is electrically neutral. Now it gains one electron. That means 17 electron becomes 18 now. So plus 17 minus 18 is equal to minus 1. So chlorine now attains a negative charge. Chlorine atom becomes chloride ion. So anion is formed. So potassium loses one electron and chlorine gains one electron. Okay. So potassium has an excess electron. Chlorine needs one electron. Therefore, potassium transfers one electron to chlorine. So potassium loses one electron and chlorine gains one electron. So transfer of electron takes place between potassium and chlorine. Therefore, ionic bond is formed. Transfer of electron means what kind of bond? Ionic bond is formed between potassium and chlorine. So the positive potassium is attracted to the negative chlorine and an ionic bond is formed. So potassium chloride is an ionic compound. Okay, if an ionic bond is there, those compounds are said to be ionic compound. So this is how an ionic bond is formed. Okay children, so next we pass on to the formation of covalent bond. How a covalent bond is formed. So what is a covalent bond? It is a chemical bond. It is formed by the sharing of electrons between two atoms. So covalent bond formed by the sharing of electrons. So look at the hydrogen molecule. So two hydrogen atoms combined together forms a hydrogen molecule. So hydrogen has one electron. Hydrogen atom has one electron and another hydrogen atom has one electron. So these two hydrogen atom shares their electron and forms a covalent bond. So sharing of electrons. So forms a covalent bond. So hydrogen atom combined together forms a hydrogen molecule. So let us look at the next example. Formation of water molecule. Water is a covalent compound because covalent bond is there, therefore it is a covalent compound. Water contains hydrogen and oxygen. So hydrogen, it has only one electron. Oxygen, electronic configuration 2, 6. So how many electrons need for oxygen? Oxygen needs 2 electrons in order to have 8 electrons in its outermost shell, so as to achieve the noble gas configuration. Yes. So oxygen needs 2 electrons and hydrogen need 1 electron to complete its shell. K shell can have 2 electrons. Yes. So therefore to complete its shell, hydrogen needs 1 electron and oxygen needs 2 electrons. So it combines with 2 hydrogen atoms and these two atoms, one oxygen atom and one hydrogen atom, shares their electrons and the shared electrons are mutual to both the atoms. It is common. These two shared electrons are common to both the atoms. So now count the electrons: 2, 4, 6, 8. So oxygen has 8 electrons in its outermost shell by sharing the electrons with hydrogen. So this is how water is formed. Okay. So water molecule, it is a covalent compound because covalent bond is there. Sharing of electron takes place between hydrogen and oxygen. Okay. So just let us recall the ionic bond and covalent bond. So ionic bonds are formed because of transfer of electrons and covalent bonds are formed due to the sharing of electrons. And ionic bond is always formed between metals and non-metals and covalent bond is always formed between non-metal atoms. Okay, so chemical bonds are nothing but attractive force between the atoms of a compound. And two types of bond: ionic bonds and covalent bond. Ionic bonds are formed by the transfer of electrons. Covalent bonds are formed by the sharing of electrons. Okay children, thank you.